What if one of humanity's most iconic relics, Mungo Man, was never what we thought he was? From the moment skeletal remains appeared 42,000 years deep in Australia, Mungo Man was more than a fossil. He was a puzzle. Early DNA results suggested he hailed from a mysterious, vanished lineage predating Aboriginal Australians. Could this be evidence that a lost branch of Homo sapiens, perhaps one lingering from the Ice Age, once shared the continent with Aboriginal peoples? That question haunted archaeologists and geneticists for decades. But now, with fresh technologies, that mystery is unraveling, and what emerges is a new narrative about human evolution, Neanderthal legacies, and the tangled paths of migration across the Ice Age world. So, did Mungo Man truly represent an extinct ghost human population, or was he a misread clue in our ancient DNA record? In 1974, on the shores of Lake Mungo in Australia's Willandra Lakes, archaeologists uncovered the remains of a man who would become a symbol of mystery and debate. Known simply as Mungo Man, he was buried around 42,000 years ago, sprinkled with red ochre in one of the world's oldest known ritual burials. For decades, scientists wondered, who was he? And what does his DNA tell us about the earliest Australians? The first big shock came in 2001. Gregory Adcock and his colleagues published mitochondrial DNA sequences from Mungo Man and other ancient skeletons in the region. What they claimed to find was extraordinary. According to their analysis, Mungo Man's genetic code didn't fit within the known diversity of Aboriginal Australians. It seemed to point to an entirely separate lineage of modern humans, possibly a people who reached Australia before the ancestors of today's Aboriginal communities, only to vanish without a trace. The idea sent ripples through anthropology. If true, it meant that Australia might have been settled in multiple waves, echoing theories of lost migrations across Ice Age landscapes. Some even speculated about links to archaic hominins in Southeast Asia, raising the possibility of human diversity in Australia far richer than anyone had imagined. But there was a problem. The 2001 results were based on PCR amplification, a method that works like a genetic photocopier, making millions of copies from tiny fragments of DNA. On fresh material, PCR can be powerful, but with ancient, degraded bones, it is treacherous. Even the faintest contamination skin cells, a sneeze, or a drop of sweat can overwhelm authentic ancient signals. And Australia's climate is not kind to DNA. The heat, the dryness, the chemistry of the soil, all of it conspires to break down genetic material. For remains tens of thousands of years old, recovery is a daunting challenge. That is why, in 2016, a new team led by Professor David Lambert at Griffith University decided to re-examine Mungo Man using far more advanced tools. They turned to next-generation sequencing, hybrid capture methods, and a technique called single primer extension, SPEX, designed specifically to target short, damaged DNA fragments while screening out modern contamination. Their results changed everything. The sequences that Adcock's team had reported back in 2001, they were not ancient at all. Instead, they matched several common European haplogroups, the genetic signatures of modern populations. In other words, contamination, likely introduced by the very scientists who had handled the bones. None of the supposed ancient sequences could be replicated. Mungo Man's remains yielded no authentic human DNA that could be used. The extinct lineage, the pre-Aboriginal population, the lost migration, it dissolved under the weight of better science. What remained was contamination mistaken for revelation. But the Griffith team did achieve a breakthrough, not from Mungo Man, but from another skeleton in the Willandra collection, WLH4. Dated to between 3,000 and 500 years ago, WLH4's bones were less mineralized and the DNA inside them had survived in better condition. From WLH-4, the scientists were able to recover not one, but two mitochondrial genomes. One was European again, contamination, but the other was the real prize. Haplogroup S2, a lineage found only among Aboriginal Australians. It carried the telltale scars of true ancient DNA, including cytosine deamination, a chemical signature of age. Analysis showed that this S2 lineage fit squarely within the Aboriginal genetic tree, clustering alongside lineages S, O, P, and M. Bayesian models suggested that the most recent common ancestor of the S2 branch lived around 28,500 years ago, with the broader lineage stretching back over 35,000 years. This was more than data. It was proof of continuity, proof that Aboriginal Australians are directly connected to the deep past of the continent, unbroken by the ghost of a vanished lineage. And so, the story of Mungo Man comes full circle. His bones may not yet have given us DNA, but his legacy remains profound. He represents not an extinct people, but the cultural and spiritual depth of the world's oldest continuous civilization. His careful burial, his ochre-stained grave, tells us of ritual and belief at the dawn of human history. The reanalysis closed a chapter of speculation and reaffirmed a simple truth. Aboriginal Australians are not the descendants of newcomers who swept aside an earlier people. They are, instead, the living continuation of a lineage that has endured on this land for tens of thousands of years. The extinct lineage of 2001 was never real. It was a mirage born of contamination and the limits of early technology. Today, with the power of next-generation sequencing, we see the story more clearly. Not a vanished people, but survival, resilience, and continuity, written in both bones and memory. The discovery of Mungo Man is captivating on its own, but his story only makes sense when placed inside the larger stage of the Ice Age, when continents looked different, climates shifted dramatically, and human groups collided and blended in ways that would define us forever. During the last glacial maximum, and in the millennia leading into it, the Earth's geography was reshaped by ice. Sea levels plunged, land bridges emerged, where oceans now divide. Coastlines stretched far beyond today's maps, exposing vast shelves of land that acted as prehistoric highways. Across this altered world, early Homo sapiens spread outward from Africa into Eurasia. On that path, they encountered others, the stocky Neanderthals, adapted to cold Europe, and the shadowy Denisovans, who left us barely a finger bone and a ghost in our DNA. This is where genetics becomes our compass. Every person outside Africa today carries around 1 to 2% Neanderthal DNA. That may not sound like much, but it is universal. It tells us that a single major moment of interbreeding occurred, likely between 45 and 49,000 years ago, somewhere in Eurasia. What's more, Aboriginal Australians and Papuans, descendants of the first people to settle Sahul, the Ice Age continent that united Australia and New Guinea, carry the exact same 2%. Their Neanderthal ancestry was never diluted, never replaced. This fact ties their ancestors directly to that same genetic meeting point in Eurasia. And this creates a puzzle. Some archaeologists argue humans may have reached northern Australia as early as 65,000 years ago. But if those first arrivals left no Neanderthal DNA, then they cannot be the ancestors of today's Aboriginal peoples. The genetic clock forces us to rethink. Perhaps the earliest settlers were outliers, small groups who came too early and disappeared, while the true founders of modern Aboriginal lineages arrived later, after Neanderthal contact. This perspective does more than clarify Australia's timeline. It binds together key threads: the Ice Age reshaping landscapes, the Neanderthals sharing genes with us, and the branching pathways of human evolution. But it also opens a larger, unfinished question. If ghost populations once lived in Australia but vanished, could the same have happened elsewhere? Across Africa, Asia, and Europe, hints of archaic humans flicker in our DNA and in scattered bones. Did entire lineages appear, survive for a while, and then vanish without leaving a trace, except in whispers of genetic memory? Mungo Man, then, is not just about one burial by a dry lake. He is part of a bigger mystery, a reminder that the story of who we are is stitched together not only by those who survived, but also by those who vanished in the deep cold of the Ice Age. The saga of Mungo Man is more than a debate about DNA. It is a mirror showing us both the power and the fragility of science. In warm, continental climates like Australia, ancient DNA erodes quickly. What remains can be drowned out by the faintest touch of modern contamination. The 2001 claims stand as a cautionary tale. If our methods are not rigorous, the whispers of the past can be replaced by echoes of ourselves. But beyond methodology, the lesson cuts deeper. Human history is not a single clean wave of migration, sweeping across continents. It is a mosaic. Groups split, others mingled, some endured, and others vanished without a trace. The debunking of Mungo Man's supposed lost lineage reminds us that the real story of human evolution is far more tangled than we once imagined. Here, the role of Neanderthal DNA becomes crucial. That 2% of archaic inheritance we all carry is not just a genetic curiosity. It is a timestamp. It marks the window when Homo sapiens stepped out of Africa, crossed Eurasia, and intertwined with Neanderthals before continuing toward places like Australia. It's a genetic anchor tying migration stories to real moments in Ice Age time. Yet science alone cannot claim the final word. For Aboriginal Australians, cultural continuity has always been central. Oral traditions, sacred landscapes, and enduring ties to ancestry have long testified to their deep time presence. When genetic evidence now aligns with those traditions, it validates not only history but identity. The reburial of Mungo Man in 2022 was not simply the closing of a scientific case, but an ethical act of respect, a reminder that behind every bone is a human story, still living in memory and spirit. So did Mungo Man truly reveal a lost branch of humanity, a people erased before Aboriginal Australians? The evidence today says no. What once looked like a divergent lineage was only an artifact, a ghost made by contamination. And yet, Mungo Man is not diminished. His story reminds us just how miraculous and how treacherous the hunt for ancient DNA can be. The larger truth is far more profound. We are all heirs of that Ice Age diaspora. Within us echo both the fleeting encounters with Neanderthals and the enduring heritage of the first Australians. Human evolution is not a straight line. It is a web of migrations, admixtures, and survival across frozen epochs. If this journey into deep time speaks to you, join us at Prehistoric Shadows. We are more than a channel. We are a living conversation about the shadows our ancestors left behind and how those shadows shape us today. So here's my question to you. If Mungo Man was not the lost lineage, then where else might the ghost stories of human evolution still be hiding?